All right. Good morning, good afternoon, good evening for everybody, depending where you are. So, as Dominique said, I'm Anami. I'm from Brazil. I work for IBM Services as a chief engineer. And today I'll be talking about how to programmatically create an application that records and retrieves secrets from the vault. So before going there, let me tell you a short sad story, right? And I will not tell you with whom this happened, but you can guess, right? So basically, I store those like API tokens on a text file. This is a common practice when you're creating a new Node.js app. But I forgot to update my git ignore file. So that means everything that is not on git ignore will be synced with your GitHub repository. And that's what happened. My pre-shows Slack API tokens, which authorize me to do public messages, create channels, and everything else on our corporate Slack grid was there on a public GitHub repository and visible to the whole company. That's not nice, folks. And luckily, and I'm thankful for that, we had a scanner that was able to detect that I published it and make those tokens available on a public GitHub repository, and that warned me within hours. So I was able to fix that before it was a real security breach or security problem. Okay, so why I'm telling you this sad story with happy ending, what we are trying to solve here, right? So like we said, we have secrets everywhere. And when we say a secret, it means user password pairs, application IDs, tokens, keys, certificates. It's not just personal secret, but every single application in the cloud nowadays uses certain kind of secrets. And of course, we need to store that securely. And of course, we also need to retrieve that so we can use when it's required, right? So today we have some practice. One of them is to pass this kind of information as environmental variables. And sometimes it's not rare to see that, unfortunately, we have no secrets inside the code, right? That's not a good thing to do. But of course, it's also a reality today. And I can say such methods are really very, very unsafe, right? You can lose, you can have a security breach, you can have a data privacy problem. So how can we store and retrieve secrets for our application safely and do that through a program or software code or an app, right? One very interesting solution is to use software vaults. It is a lightweight solution. It is an elegant solution because it's very comprehensive. You can do everything with those secrets, not just create them, but renew them. You can not just store, but you also can manage their life cycles as well. And one of the solutions that we have in the market, and I can say it is one of the best solutions we have in the market today, is the HashiCorp Vault. Okay. I just put a simple diagram here. Of course, this is a simplified one, but you can see on this diagram that you have two things there, right? You have authentication and secrets engine. Okay. Basically, what you need to do is to have a secret engine to create, manipulate, change, store, or retrieve your secrets. And you have authentication methods to authenticate yourself before you can get access to those secrets. I can also say that the Vault server is very secure. It has, three layers of encryption, right? It's almost impossible, virtually impossible to break through the three layers of encryption. And this is also good news. The Vault server has an API. So everything you can do through commands and console, you can also do the same through the API. Actually, when you issue a command on the command line interface to manage the Vault server, actually it calls the Vault server API. The same is true when you go to the console. Um, Everything that is happening behind the scene is callings to the Vault Server API. Okay, so this is a very good solution if you think about how to store and retrieve secrets in a very safe way. And how I do that through a program or software piece or an app. You can use HashiCorp SDK. Okay, you have SDK for Node.js and other languages. Everything is available on this website. I shared this presentation on the discussion thread, so you can see there is a direct link to all the libraries that you can find to use and utilize our Vault API endpoints. And what I did here was to create a smoother way, if you like. This is a helper library that is available on the public NPM website. And this simplifies even more the way you can access the Vault Server API. So that's why I'm saying using the API without sweat. And you can see this is licensed as Eclipse public license, so anyone can use this helper library. The requirements are stated there. You need to use at least Node.js version 12 at minimum, NPM package 6.4, and it was tested on HashiCorp Vault versions 1.4, 1.5, and 1.6. Actually, we are going to have a demo in a few minutes, and I'm going to show you a live application trying to store and retrieve secrets from the Vault. It was written using this helper library, and it's working on a Vault server version 1.6.2. Okay, you can see today we have like 2,600 downloads per week, but we had a peak when we released the latest version. It rated like 7,000 downloads per week. So we see this helper library is very helpful to the community because the number of downloads per week. Going there, before I talk through this application, how to create this application from scratch, let me show you this work on a development environment. Let me go to my computer. And first of all, let me show you the helper library, some additional details here. You can see you have a class constructor intended to mainly to use a secure way to contact the Vault Server API through HTTPS. So this was one requirement from one of our products. We need to have an encrypted way to talk to the Vault API server by default. Okay, so you are able to create your own certificates and use them to create this encrypted communication with the Vault server. Also, you can see you have additional options that is from Axios. We are using Axios here as the way to do HTTP calls to the Vault server API. And one thing that is pretty good is the root path. So imagine that you enabled one of the secret engines on a different path. You can change the root path so you can use the proper mount for your Vault server API secret engine. So everything that you see here is configurable. And of course, every day we're expanding these to use more and more API endpoints. Today, let me go down there. we covered those authentication methods. So how you authenticate your application in order to store and retrieve based on policies. So you have the AppRole, LDAP, user pass. So this is the the common user ID, pass, pairs, and token. Okay, and in terms of secret engines, we have helper libraries to the key value version 2. And you can see all endpoints from Vault Server API are covered here on this package, and also PKI. So you are able to create your own TOS certificates, both private keys and certificates. So everything is available on this NPM package. Okay. So let me go to my command line interface. I just created this repository, and it is available for the public. So if you want to see the same thing that is here on this demonstration app, it is available under my name in the public GitHub. So all you need to do is to clone this repository so you have access to everything I'm doing here. The way I had configured this Vault server, also how I create this application from scratch. So I have everything here, even the certificates that PKI certificates that I create to use HTTPS communication with the Vault server. So my Vault server is running on a Docker container. You can see I'm using 1.6.2. It is the latest one as of yesterday. I didn't check today, so I'm not sure if we have a new version. I don't think so, but you see I have the standard Docker image running on my local machine here, okay? Of course, if I do a Vault status, the Vault is unsealed because I did that. But keep in mind, every time we restart the Vault server, it will begin as sealed, right? So you can't access the API unless you unseal the Vault. And luckily, we have helper functions in that library that unseal the Vault for you, as long as you have all the, of course, all the tokens required for that. So going on, let me show you my application. So to a simple storing and retrieving, I'm using a JavaScript application that has 65 rows. You see, it's not difficult after you understand how to work with the Vault API, and this helper library will help you a lot, okay? So everything I need to do is to use one of the available auth methods. In this case, I'm using the AppRole authentication methods from the Vault server API, which means I need to have a role ID and a secret ID. Keep in mind, this secret ID is ephemeral, right? It's temporary. There is a time to live for the secret ID, but you can, of course, create these and renew the secret ID or create this as secret ID programmatically. We don't have time to do this right now, but it's possible to do that. Everything that is required to have these two pieces of information, you can do this through the API and through the NPM package that I'm talking about, okay? But let's assume we have these two pieces of information. It is on process env file, process in text file per se, okay? Don't tell anyone, but I learned my lesson on this. But anyway, just for the sake of brevity, I'm using a process env file just to give me the role ID and security. You can do that programmatically, okay? But of course, I will need to create code inside this app to accomplish that. Then you can see I use this npm package, hash-vault.js, and I instantiate a new class, okay? And of course, I'm using HTTPS, so I have a secure communication with the Vault server through its API. And I'm using a root path secret. So my mount point inside the Vault server is secrets, okay? I could enable any secret engine on a different path, and I would need to change that here, but for this demonstration, I configured my Vault server to use secrets, which I think is the default path. Inside this repository, you can see how I have configured this Vault server. And the details about my policy. You need to have a policy, of course, in order to associate the role ID with a certain privilege. So basically what a policy does is, okay, when I create a new token, which privilege this token will have, and this is determined by the policy, okay? I want to go into much details in the Vault server itself, because I think we have many other presentations about the Vault. I'll try to focus on my app here, okay? So with that, let me show you the results first. Okay, so basically I will go to the demo app, and you see I'll do npm start here. And if it is still working, yeah, it is. You can see some things I'm doing to the Vault server. First thing is the status, right? I need to understand if the Vault, the sealed, are available, right? This is the first thing you need to do on any app. So I can see it is not sealed, so it is okay to do operations. And it is also initialized. So that means I have configured the initial token, root token. I have configured do an initialization of the Vault. And as I mentioned, every time you restart the Vault, it gets sealed, right? That's not the case because I have unsealed before this live demonstration. So since Node is not sealed, I can use it. Then I obtain an authorization token. Okay, so this is a token. I do that by authenticating myself. So I pass the role ID in the secret ID. And with that, I say, okay, Vault, I have this role ID, which is associated to this policy, and I want a new secret ID. This is my secret ID. Please give me an API token. And the Vault returned my API token. With this API token, now I can do some operations. The first operation is to store key values there. So you can see I stored the user pass there, a username and a password. I have stored a bot token, a Slack token per se. Of course, this is a made up one. So you can see I can store any type of secrets in key values using this engine. I also stored MySQL database password. In this case, this is the root password. Okay? So if I go to the Vault console and make sure they are there, and this is the UI. So the Vault server has not just API, it has a command line interface and a UI. And remember, the UI and the CLI will call the API, okay? Everything happens on the API level behind the scenes. So under my secret engine, which is version 2 of key value, I need, of course, to refresh. And it will ask you again my token. This is the root token. Of course, the recommendation is not to keep the root token, but create a new one. And you can see under secret, I have those key values, right? A Linux login, and I can, of course, expose those values if I want. By default, will be that way. Yeah, I have my SQL login and my Slack bot tokens. Okay, and I just list that through the program, but you could also just read one of them on the values, right? Use it on your app. So with this, 65 rows demonstration app, I first checked if the vault is available for operations. Then I stored some key values there and retrieve it um, later, to see what is there. So let me pause here and go back to the presentation and give you more details about the code. Okay. So if you want to know specific instructions, of course, you initiate by creating a new product, a new Node.js or JavaScript product. And as I told you, the first thing to do is to unseal the Vault server, right? Because it starts as sealed and you need to unseal before anything else. You can do this through the API. We have, like I mentioned, helper functions to do that. But here I'm showing you how to do this through the COI. So which commands you need to issue in order to unseal a Vault server. In this case, initialize this Vault to use 6 different keys, and you need to provide 3 different keys at least. Okay, so it's a 3 by 6 Shamir configuration. And that means it will generate 6 keys, yeah, and you need 3 to unseal the Vault. So it's very, very safe, right? Like I said before, you have at least 3 encryption layers. The first one is this one here, is the Shamir algorithm that seals the whole Vault. You need to unseal that so you can have access to encryption keys that are used to finally encrypt the values in the file system or the database or any data source that is connected to the Vault. Okay. Um, like I said, you need to initialize or instantiate the class, so you need to create a new object. You have those options. So for us, it's pretty important to use HTTPS, right? So we need a totally secure communication with the Vault server API. So this is a requirement for our products to use two-way multi-OTS authentication. So we need to have our, not just the CA certificate, but also the client certificate with the private key. Root path, as I said, you can have a different mount point inside the Vault server. You can configure your secret engine on different mount points. So you have this option to accommodate that. And then, I'm cheating here because, cheating because I'm getting the role ID and secret ID from the file, right? But I could do this programmatically. You can see, how to do that on the NPM package documentation, how to use the AppRole authentication methods in order to create a new role ID or renew this secret ID. But you need both to authenticate yourself or authenticate your application, better saying. Then how I do this health check, I just call this method from the NPM package, which is health check. There is no parameters. And then I check for results, right? If it is an error, then I just expose that. Or if it is open and unsealed, then I do stuff. Okay. You can see here after I check if the status is not sealed, so you can see that this is the condition to run the rest of the code. I do a login with AppRole. So that's where I authenticate my application with the Vault server. I'm saying I'm in this application, I have this role ID and this secret ID. The Vault server will check if this role ID is valid, and if the secret ID is still non-expired state. Okay, if it is not expired, then it will authenticate myself, my application, and give back an API token. And with that API token, I can create a secret inside the vault using the KV method. And then I listed those secrets that are just stored. So with this 6.5 rows app, you can store as many key values as you want and list them before. I can also read the specific ones I didn't put in my demonstration application, but there is a method just to read a specific KV entry there, okay? So I think we are running out of time. Then let me talk about lessons, right? Key takeaways from this demo. First, right? Errors happen, right? It's not something that everybody disagrees, right? So with that in mind, what can happen is your secrets, or better say, your application secrets can get exposed, and that's not good. You can have, for example, like I mentioned, a Slack token exposed, which gives ability to send messages in your name, or in theory, someone could get a message from me to my boss saying, I quit. That's not fair, not good. So keep in mind that will happen for sure. Vaults are here to keep our secret safe, not just our secret, but also application secrets. So on a microservice architectural design, on a world with service meshes, the number of secrets are exponential, right? We need an elegant, lightweight solution for that. And Vault's API is very simple, very easy to use. And if you use this helper library, of course, it will be easier, much easier if you want. And if you need no reference, I put this on my presentation. This is where the npm package is located and all the docs. I put this demonstration also on this GitHub public repository. And if you want to reach me out, this is my LinkedIn profile. So thank you. Not sure if we have time for questions. I'll stop sharing now.